Hey everyone, in this video we'll learn about how to deal with absolute value equations and how to solve them. So just as a reminder, what does it mean to take the absolute value of a number? So let's say the absolute value of 3. All the absolute value does is just make the number, whatever's inside the absolute value, positive. So 3 is already positive, so the absolute value of 3 is simply 3. And the absolute value of negative 3 is also 3. The absolute value of any negative number, so negative 2 is 2, and the absolute value of positive 2 is also 2. It simply makes it positive. If it's already positive, then no change, and if it's a negative, it makes it positive. So that's all an absolute value does. Now, how do we deal with this in the context of equations? So let's say we had the absolute value of x equals 2. Okay, so we have this mini equation right here. So our goal with any equation is to solve for x. We want to isolate this x. And what's getting in the way of x being isolated? Well, it's these absolute value bars right here. So how do we get rid of the absolute value bars? Well, whenever we come across this situation, we can break this up into two equations. So we can have x equals 2 and x equals negative 2. And those are our solutions. So in order to drop the absolute value bar, you have to make it equal the other side of the equal sign. You have to make it equal the positive version, so positive 2. Over here, positive 2. And you have to make it equal the negative version as well, negative 2. So put more generally, if we had the absolute value of x equals a, x can equal a, and x can equal negative a. And that's how you drop the absolute value bars right here in blue. So let's go through an example together of a more complicated absolute value equation. Let's say we had the absolute value of 3x plus 1 equals 10. Okay, so we have these absolute value bars over here. Now how do we drop them? All we have to do is split this up. So we can free this 3x plus 10 within it. So we have 3x plus 1. So we have this 3x plus 1 equals positive 10. And on the other side, we have 3x plus 1 equals negative 10. So that's how we drop the absolute value bars. So let's go ahead and solve this equation on the left first. So let's subtract 1 from both sides. So we'll subtract both sides by 1. And we have 3x equals 10 minus 1 is 9. And then we'll go ahead and divide both sides by 3. And x equals 9 over 3, which is 3. So we have one solution there for x equals 3. So x equals 3 right here. And now let's go ahead and solve this equation. So we will go ahead and subtract 1 from both sides. So minus 1 and minus 1. And we have 3x equals negative 10 minus 1 is negative 11. And we'll divide both sides by 3 to isolate the x. We have x equals, so I'll write it up here, x equals negative 11 over 3. There we go. Now, just like with radical equations, it's very important to test for extraneous solutions. So we can go ahead and test these two, x equals 3 and x equals negative 11 over 3. So let's actually begin by testing this x equals 3. So let's rewrite our original problem. Our original problem was absolute value of 3x plus 1 equals 10. And we are going to substitute the x for 3. So 3 times 3. And let's go ahead and evaluate. 3 times 3 is 9. And then 9 plus 1 is 10. So we have the absolute value of 10 equals 10. And what's the absolute value of 10? That is simply 10. So 10 equals 10. And 10 does equal 10, so that checks out. So x equals 3 works. Perfect. Now let's go ahead and test our other answer right here. X equals negative 11 over 3. Let me just write that down in orange. So x equals negative 11 over 3. And let's write our original problem again. So our original problem was the absolute value of 3x plus 1 equals 10. And we are just going to substitute our x for negative 11 over 3. So let's go ahead and do that. So let me just move the plus 1 a little bit here. Okay, so times negative 11 over 3. And you could see right here, we're multiplying these two fractions, 3 over 1 times negative 11 over 3. The 3 in the numerator and denominator cancel out, so we are left with negative 11 over 1, which is just negative 11. So negative 11 plus 1, the absolute value of that equals 10. Now what's negative 11 plus 1? That's negative 10. So the absolute value of negative 10, so this value is to negative 10. The absolute value of negative 10 equals 10. And what is the absolute value of negative 10? That is 10, positive 10. So 10 equals 10 is what we're left with. And that checks out. 10 does equal 10. So therefore, our answer right here of x equals negative 11 over 3 is perfectly fine. So both of our answers check out. And that's how we solve this absolute value equation we're given. So let's go through a more complicated absolute value equation. Let's say we had, so down here, the absolute value of 3x plus 2 minus 5 equals 5x. Okay, so before we can drop these absolute value bars down here, or over here, these absolute value bars, we have to actually isolate this entire absolute value term. In order to do that, we're going to move this negative 5 to the other side. So in order to get rid of the negative 5, we will add 5 to both sides. And we have the absolute value of 3x plus 2 of 3x plus 2 equals 5x plus 5. Okay, and now we can go ahead and split this up in order to drop the absolute value bars. So we can go ahead and free what's inside the absolute value. So we have 3x plus 2. It equals positive 5x plus 5. So positive 5x plus 5. And this is important. So on the other side, you have 3x plus 2 equals negative. So negative. And then in parentheses, 5x plus 5. And it's important to put that parentheses because you're taking the negative of the entire binomial, of the entire right side of the equal sign. It's not just going to be negative 5x plus 5. It's going to be negative parentheses 5x plus 5. And that's the important part right here. That's the key. So let's go ahead and solve each one. Let's start with this one on the left. So we can go ahead and actually just, let's subtract both sides by 2. We have 3x equals 5x plus 5 minus 2, so 5x plus 3. And let's actually now subtract both sides by 5x. And we have 3x minus 2x, that's negative 2x, equals 3. And then we will go ahead and divide both sides by negative 2. So divide by negative 2, divide by negative 2. X equals negative 3 over 2. Okay, so that's one answer, which we will test. And now the other answer, so this other equation right here. So what we can do is we are going to distribute this negative sign within these parentheses. Because we have a negative sign outside of parentheses, we have to distribute it. So what does a negative sign do? Well, it just flips each term. So what's the opposite of positive 5x? That's negative 5x. And what's the opposite of positive 5? That's negative 5. Good. And let's write the rest down. 3x plus 2. And let's go ahead and continue solving this. So we can subtract 2 from both sides. 3x equals negative 5x. And then minus 5 minus 2 is minus 7, negative 7. And now we can move this negative 5x to the other side by adding 5x to both sides. So we have a minus 5x, so we can plus 5x to both sides. What's 3x plus 5x? That is 8x. So 8x equals negative 7. And in order to finally isolate the x, we can divide both sides by 8. So x equals negative 7 over 8. Great. And let's just write that again. And then let's go ahead and test both of these solutions and see if any of them are extraneous. So again, what's our original problem? The absolute value of 3x plus 2 minus 5 equals 5x. So let's write that down here. The absolute value of 3x plus 2 minus 5 equals 5x. So let's actually test this one first, negative 3 over 2. So we're going to substitute negative 3 over 2 for x in this spot and in this spot. So let's go ahead and plug it in. So the absolute value of 3 times negative 3 over 2. So negative 3 over 2 plus 2 minus 5 equals 5 times negative 3 over 2. Okay, so let's start evaluating. What is 3 times negative 3 over 2? So 3 over 1 times negative 3 over 2. 3 times negative 3 is negative 9. So negative 9. And over 1 times 2 is 2. And then plus 2, absolute value, minus 5 equals, and now over here, what's 5 over 1 times negative 3 over 2? So that is negative 15 over 2. Because 5 times negative 3 is negative 15, and 1 times 2 in the denominator is 2. Great, so let's keep evaluating. How do we add these fractions, or negative 9 over 2 and positive 2 over 1? So the least common denominator is 2. So to get them to have the same denominator, 2 over 1 is the same as 4 over 2. We can go ahead and evaluate. What's negative 9 plus 4? That is negative 5. So negative 5 over 2 minus 5 equals negative 15 over 2. And what's the absolute value of negative 5 over 2? That is positive 5 over 2. Minus 5 equals negative 15 over 2. And again, to have these have the same denominator when subtracting these fractions, so 5 over 2 minus 5 over 1, least common denominator is 2, so 5 over 1 can be written as 10 over 2. And great, what is 5 over 2 minus 10 over 2? That is negative 5 over 2. So negative 5 over 2 equals negative 15 over 2. And right away you can tell this is wrong. Negative 5 over 2 does not equal negative 15 over 2. So our first answer of negative 3 over 2 is extraneous. This is extraneous. So this is not a solution, negative 3 over 2. And let's go ahead and test this one now, negative 7 over 8. So we'll do the same exact thing. Let's go ahead and just get rid of these. And we'll do the same exact thing for negative 7 over 8. So let's go ahead and go through it quickly. So 3 times negative 7 over 8 plus 2 minus 5 equals 5 times negative 7 over 8. So it's 3 over 1 times negative 7 over 8. That is negative 24 or apologies, negative 21. 1 second, negative 21 over 8 plus 2 minus 5 equals, and then 5 over 1 times negative 7 over 8. That is negative 35 over 8. And let's keep going. Negative 21 over 8 plus 2. So in order to have them have the same denominator, 2 over 1. So we can multiply the top and bottom by 8. So 2 times 8 is 16. So 16 over 8. 16 over 8. Good. Now it's negative 21 plus 16. That is negative 5. So negative 5 over 8. The absolute value of that minus 5 equals negative 35 over 8. And what's the absolute value of negative 5 over 8? That's positive 5 over 8. So minus 5 equals negative 35 over 8. And again, to subtract these two fractions, 5 over 8 minus 5 over 1. Least common denominator is 8, so we'll multiply the top and bottom by 8. What's 5 times 8? That's 40 over 1 times 8, which is 1, so 40 over 1. So 40 over 1. Or apologies, 40 over 8. 1 times 8 is 8. So 40 over 8 is the same as 5. So it's 5 over 8 minus 40 over 8. So it's 5 minus 40. If we just subtract the numerators, 5 minus 40 is negative 35. So negative 35 over 8 equals negative 35 over 8 on the other side. And as you can see, negative 35 over 8 does equal itself. So that checks out. Therefore, our answer of negative 7 over 8, it's legit. It's not extraneous. And that is a good answer to this absolute value equation. So that's how you solve absolute value equations. Just remember to watch out for those extraneous solutions. Make sure to test your solutions to make sure they're right, to make sure they're not extraneous. I really hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.